Let's do an example that uses Tcheby. So here's the example I did in class. Y is a discrete random variable. Its mean, or the expected value, also called mu, is 243. And the variance, also called sigma squared, is 19.36. Okay, so instead of talking about the variance, I want to talk about the standard deviation. So I'm going to take the square root of the variance here, and it's approximately 4.4. So here all we know is that y is a random variable. Then what's the probability that y is in between these two values? Okay, so again, we don't know what shape it is. No idea. I've just drawn it like this. I have no idea what shape it is, but here I've drawn it. I do know the middle, the expected value, is 243, and I'm looking for the area in between these two points here, this point and this point. So what I want to know first is how many standard deviations away is this number from this number. So how many times do I jump to get there? Or how many times do I jump to get backwards to here? Okay, so here to find how many jumps, how many standard deviations, this is just the middle, the expected value, 243, plus some number of jumps multiplied by the size of the jump, which is 4.4. And I'll set it equal here to this upper bound. Okay, so then I'll just use some algebra quickly to rearrange for k, and I find that k is 3. Okay, so here I was using this part, the right side. I could also find k by doing the left side. Here I've got 243, which is the middle, subtract, so I'm going left, k amount of jumps where the jump size is 4.4 is equal to this lower limit. Okay, again, I can find out this k using a quick amount of algebra. Should be 3. So here I've got a symmetric number of jumps, as I always should have a symmetric number of jumps when I'm using the Chebyshev formula. So Chebyshev cannot tell me exactly what this area is, but it can tell me the smallest this area could possibly be. So this area is at least 1 minus 1 over k squared. Okay, so a few things about k. K has to be 1 or larger to make this example work. Okay, if you've got something smaller than 1 for k, you're going to get crazy answers here. So k has to be 1 or larger. In this case, k is 3, so we're okay. So this shaded area is at least 8/9 large. It could be bigger than that, but the smallest it could be is 8/9. The other version of Chebyshev's you could see is, instead of calculating the inside area between 2 points, you could be talking about the outside area. Okay, so here's an example of that. If y is greater than or equal to 260.6, so greater than, that would be this area. Again, I don't know what shape it is. I've just drawn it kind of crazy here. So here, this area, or union, okay, this combined with this area, y is less than 225. Okay, so these two areas together. I'm not sure if it'll be half and half, or if all of the area will be in the left side or in the right side. It doesn't matter, but I do need to keep these things together. Both of these outside areas together will be, the largest it could be is 1 over k squared. That's the largest it could be. It could possibly be smaller than that. So again, how do we find what k is? Again, here's my upper limit, here's my lower limit, here's my middle. How many times do I need to do a standard deviation to get here? I can just take the expected value plus k amount of standard jumps, set it equal to the upper limit here, solve for k. Or I could do the middle, subtract a k amount of jumps times by how long those jumps are, and equal to the lower limit, and solve for k. In this case, again, I get k is equal to 4. So I know that this shaded area, these two shaded areas together, the largest they could possibly be is 1 over k squared. Again, k must be at least 1. Here it's 4, so that's okay. So 1 over 4 squared. I know this area, the largest this area, this shaded area could be, is 1/16.